For centuries, an 18-kilometer stretch of the Baltic Sea between Germany and Denmark, known as the Fehmarn Belt, has forced travelers to go the long way. What's the long way, you ask? Well, currently the only route from Germany to Denmark via land is up and all the way around the Baltic Sea, adding hundreds of extra kilometers to the trip. More recently, cars and trucks can cross here via a 45-minute ferry ride, which works fine, but doesn't facilitate easy trade by rail, still requiring all trains to make the longer trip. But what if you don't want to go the long way around or wait for a boat? Well, Germany, Denmark, and the EU finally said enough's enough. Introducing the Fehmarn Belt Tunnel Project, a €7 billion engineering marvel that will be the world's longest immersed tube tunnel once completed in 2029. Construction began in 2020, and the future tunnel will offer 3 lanes of traffic in both directions, plus rail in both directions, shortening the crossing to only 10 minutes by car or 7 minutes by rail. We are about to tour the entire tunnel manufacturing, yes, I said manufacturing, process, but first let's discuss why they chose this method in the first place. In 1963, Germany built the Fehmarn Sound Bridge, connecting mainland Germany to Fehmarn Island. People were closer to reaching Denmark and Scandinavia faster, but the 18-kilometer Fehmarn Belt still stood in the way. In the 1990s, discussions of bridging the gap began. During feasibility studies, officials determined a bridge was possible, but extremely expensive due to lackluster ground conditions and the long distance. Which is then why they arrived at the third and final option, an immersed tube tunnel. Simply put, you dig a trench across the seafloor, build the tunnel pieces on land, float them out to sea, then sink and connect each, forming an underwater tunnel. At this point, there are 2 main operations: the marine construction and the tunnel element manufacturing. This video is part 1, featuring the tunnel elements, while part 2 will focus on the marine construction. The tunnel was composed of 89 total elements, with 79 normal elements and 10 special elements. And being as massive as they are, crews are making them all on site. And step 1 of that is reinforcing steel, which is where we go to right now. With all these massive concrete elements, we need a ton of steel, which means a lot of welding to build all of the panels necessary to insert within that formwork to give the concrete elements that tensile strength that concrete lacks. So in this building, it's about 18,000 square meters. They're bringing in the raw steel on one side, bundles like this. They're loading that raw steel into this machine back here, and this machine then is contact welding that steel together in a very specific way to form those prefabricated panels. Those fabricated panels then go out that side of the building, and then they go to the production halls where they'll be inserted into the formwork. Oh, I see.
So these are the intermediate layers panels with a L profile as a spacing.
Yeah.
We've got one every 150 centimeter to ensure the stiffness of the panels. Mm-hmm. And as soon as we have 7 to 8 panels into the rack is exiting outside the factory through this transfer table.
Okay.
So this machine is a prototype that was developed for this project, especially for this project. And also those racks, we've got a specific connection point with the racks to avoid any human activity inside the machine.
Yeah. Oh, wow.
That's one big ass magnet.
Yeah, it is a big magnet.
So the thread bars are delivered by shipment, 5,000 tons for each delivery.
Gosh, magnety.
Yeah, hold on if you're in teeth fillings or implant screws.
Yeah.
And we can take 2 bundles in one row with this magnetic. 2 bundles in one row. And the bundles, they are roughly 2 tons per bundle.
That'll do it. That'll do it. And then at the other end of the plant, we have this area dedicated to cutting and shaping some of the steel elements here. Over the course of a 1-week period, they'll make about 75,000 elements just like this. After crews bend and sort the reinforcing steel, it all makes its way to one of 5 production lines, and we're going to go check out one next. Wow.
Yeah. So what you see here is the bottom slats of 2 different tunnel segments being assembled at once.
Oh, so here's closest to us is one.
Yes, and then there's a dividing
the other
line.
One's on the other
yes,
side.
the other production line, yeah. This hall is about 100 meters wide, so it's quite big.
Wow. So this is step 1.
Yes.
Forming up the floor.
You could say that, depending on if you call panel factory step -5 or whatever.
Yeah. Technically, that's
You say that's where the elements begin their journey in a puzzle piece,
Sure.
and this is where we assemble the pieces, and then moving through the first half of the factory, we'll have an assembled cage, a rebar cage, the structural skeleton really of the segments, and then we'll move into the casting hall later.
Amazing. All right. This is the next step in the structural steel process. We've built out the floor. The floor has then been jacked over here to the next step, and those pre-made walls over there are lifted over to here, and the wall is then married up with the floor. So we have different walls through the tunnel section to form the different tunnels, and then we can start on the top of the segment to create a full rebar cage for a full segment. These tubes right here are what we've seen with a lot of other concrete. These are for tensioning cables, concrete strong with compression, weak under tension, and as these enormous segments are being positioned, that's a lot of force on that concrete at any given time. So they're gonna run steel cables through these pipes after this is poured. They're gonna put tension on those cables, so the cables will be pulling in, compressing the segment in on itself, and then once they've set these segments, they want a little bit of flexibility, so they'll actually cut these cables and allow the segment to relax a little bit once it's on the bottom of the ocean. To clean up my terminology, this is one segment, and then each element, which will be floated out into the ocean, is made up of 9 of these. So they have to create 9 of these enormous cages, put them all together as one element, and then that will be poured. That's what we're about to see. But this is a finished segment cage. We've got the floor, we've got the walls, and then we've got the top part of the box. I have never seen a rebar structure like this before. The scale is immense, and just how dense the rebar is also quite spectacular. This is the outside of one of the segments. This will be vehicle traffic in here. Then that service tunnel is right next to us. Vehicle traffic, rail tunnel, rail tunnel. So this is just a small fraction of a segment, and a segment is just a small fraction of one element.
We have all these textile ducts which supply even with hot air or cool air to either cool it down or heat it up. So that's a whole. It's kind of an aircon system. Aircon.
So that's why, as you were saying, this is indoors.
Yes.
Because the temperature has to be consistent for these to cure right.
The whole idea is to cast every second in the same environment. So that means that in this temperature difference, we can work with to cast the segments.
Yeah, that's phenomenal.
Yeah.
We're gonna climb to the top. Sense of scale, now we're on the top of one of the segments. This is absolutely enormous, and in just a few days, this will all be covered in concrete and curing for the next step in the process, sliding it out this building and into the wild. Here is the first segment that was poured for this element. Once this segment was poured where I'm standing right now within this formwork, it was slid further in that direction to make way for this second segment, which is now being set up now with the formwork all around us. Once this is then poured, it's slid further to make way for the third segment. And they keep sliding it and sliding it and sliding it until they've poured all 9 segments within that element. And at that time, the element is out of the building and ready to be floated. So fabricating it like this in 9 pieces not only saves a ton of space.
It's only for transporting and submerge the element that we have this post-tensioning.
But the element itself, this is what makes the element itself flexible, like what you were saying.
Yeah.
I get it. So
Before we continue, let me explain how the tunnel flex works with this visual aid. As you can see, thanks to my fancy snake toy here, as I bend it, the joints flex without falling apart or being damaged. While the flex in this example is definitely exaggerated, this is essentially how the tunnel is able to flex without any problems.
it's not just each element interlocking with each element that provides flexibility. The element itself.
It has nine flexible joints.
Yeah.
That means you have a chain of 711 segments
Okay.
plus the special elements.
Yeah.
And that gives it a much more sway.
Which makes a lot more sense. Yeah, that
It would
provides.
be a very rigid structure, even over 18 kilometers. It's only 217 meters joints.
Okay.
Yeah.
So the benefits of doing it is you don't need a giant building. You can pour this amount of concrete. It's a manageable amount of concrete to pour in one go.
Yeah.
Because if you had to pour a whole element, that's next to impossible.
Yeah.
I want to say it's manageable, but it is pushing the envelope
It's
of
pushing
what's
it.
possible.
Yeah. But it's not. We're not going over the edge there.
No.
And then it also provides significant engineering benefit of making it more flexible.
And
This is the end of one of the elements, the fabricator up there in the boom lift, good scale, these are absolutely enormous, is building out this steel ring that will go all the way around the end of the element. And this is critical because that is where the Gina gasket will sit. The Gina gasket is this rubber squishy gasket that will be sitting on that element, and as it connects to the other element, they'll be using a vacuum, and the vacuum will bring those 2 elements together, and that gasket will be in between, squeezed in between, which creates that watertight seal while it's at the bottom of the ocean. We're outside of lines 3 and 4. This is where that element that we saw getting built inside will eventually be slid to, and then it will get slid into that dry dock area where those 2 elements are sitting right now. There's some final prep work that all of these workers are doing on these elements before one of the most critical parts of this whole operation happens, and that's the flooding of that area. To flood the area those elements are sitting in right now, there's a movable gate right over there. That movable gate will slide into position and will cover those elements from our view here, and then they'll be able to fill that area with water to float both of those enormous pieces of engineered concrete. How do you get a element which weighs 73,000 tons from where it's sitting right now on land to where it needs to be placed out on the tunnel alignment? Well, that is where this area comes in here and water comes into play. They are fitting bulkheads on either side of those elements there so that it is airtight. And then the gate will shut behind those two elements, and this entire area will then be filled with water above almost those two elements. As the water starts to rise, believe it or not, those will both float because they're sealed off and they have that air within. So they will be buoyant and then they will float them. The tugboats will pull them out into this area here, which is deeper water, and then they'll lower the water down to sea level. Once it's at sea level, tugboats can grab these two elements and pull them through this little channel here out into the work harbor, where a little bit more work will be done to them, a little bit more weight will be done to them, and then they'll be ready to be towed out to the ocean to be set on the seafloor and connected with one another.